Hello to everyone in Hanoi at the Vietnam Asia Smart Cities Summit. It's truly an honor for me to be speaking with you today. I trust that you're all getting a lot of value from the discussions you're having. It's through forums like this, combined with a strong desire to innovate that you have, Vietnam and other Asian countries have a significant opportunity to be world leaders in smart city planning. My name is Craig Niles. I'm a planner and a place specialist based in Sydney, Australia. I'm the team leader for the Ramble team delivering the ASEAN Australian Smart Cities Trust Fund. I will speak to you today about the importance of integrated data to support locally led analytics, urban scenarios, visualization, and decision making. I will focus on some of the work we are doing under the Trust Fund, namely the Hue Smart City Digital Model for Urban Spatial Planning, the Makassar Data-Driven Livable City Plan and Digital Ecosystem, as well as sharing brief examples of where data is being used to assist smart city planning in Australia, including a national program for open data source and the Perth Smart City Sensors and real-time monitoring dashboards. I wish to acknowledge the First Nations people and traditional custodians of the land I am on today, the Gadigal people of the Eora Nation, being this place we now call Sydney. I recognise their continued connection to country and that this connection can be seen through stories of place and cultural practices such as art, songs, dances, storytelling, and caring for the natural and cultural landscape of the area. The ASEAN Australian Smart City Trust Fund is a program funded by the Australian Department of Foreign Affairs and Trade and managed by the Asian Development Bank. I recognise the support provided through both the Australian government and through ADB. The Trust Fund is focused on supporting cities in Southeast Asia with adopting smart city interventions with a specific target of supporting climate resilience and gender equality, disability, and social inclusion. An important part of our work is to share through learned experiences. In the Trust Fund, we are creating a network of cities and experts who can support cities with their smart city journey. With the Australian government being the donor for the Trust Fund, we are connecting participating cities with Australian cities and experts, as well as bringing learnings from across the globe. Ramble is a Danish company with a long history of supporting and delivering innovative projects for smart, livable, and resilient cities. We are coming towards the conclusion of the current phase of the Trust Fund, and we're excited to be able to share some of the successes of the Trust Fund with you. One of those exciting projects we're delivering under the Trust Fund is a smart digital city model for urban master planning in Toi Tien Hue. The development of a smart digital city model for Hue province is supported by the Trust Fund in a manner which contextualizes the model with the Hue Provincial People's Committee's plan for sustainable development of Hue as a smart and livable city. As the historic capital of Vietnam, Hue is experiencing rapid urbanisation and faces challenges related to future development and infrastructure demands, as well as climate resilience. Traditional urban planning approaches are insufficient to manage large-scale development, necessitating a digital platform that enables planning, analysis, communication, and collaboration. The Smart Digital City model covers an area of 350 square kilometres and uses a satellite dataset to generate a procedural or data-driven 3D model. This offers a cost-effective solution that captures a larger region compared to alternative data capture measures. The model's workflows and applications allow for data augmentation and capacity building to adapt to the city's growth in the future. The Smart Digital City model serves as a platform that supports government in various aspects, It aids the protection of culturally significant areas. It seeks to attract investment, promote orderly development, improve design outcomes, and facilitate inclusive, resilient, and sustainable city growth. By visualizing and analyzing future development scenarios, the Smart Digital City model fosters meaningful collaboration across many stakeholders, including government, community groups, and citizens. This initiative showcases the potential of a 3D planning as a powerful tool in modern urban master planning, empowering government to make informed decisions, optimizing resource allocation, and promoting long-term prosperity. The elements of the Smart Digital City model include a 3D model of the existing conditions within Hue, and this uses ArcGIS as the software basis. We have used the satellite data to create a large precinct-based 3D model, as well as collecting GIS data from across different departments. The idea for the 3D model is to have an integrated GIS database as a single point of truth. Super user training is a critical part of the work that we're doing to train the trainers. In other words, to train key users of the 3D model so that those users can operate the model, as well as training other users within the city. We will wrap this up both in the digital city model itself, but also a model report, which provides a background to the model development, as well as instructions on how to operate and maintain the model. Locally led development and capacity building to ensure long-term sustainability of the model and encourage innovation locally are critical. Not all cities are the same, which means not all 3D models are the same. It's important for us to create the digital infrastructure for cities to grow and develop locally. The satellite data allows us to generate a province-wide 3D model at much cheaper rates than you would otherwise have with other data capture measures. The satellite data also has been through a testing and validation phase, which resulted in a much higher level of accuracy than other similar models. The model is focused on the precinct scale master planning at approximately a scale of 1 to 2,000. We've also created digital workflows that enable users in Hue to add new buildings and undertake GIS analytics much more easily. And as a data-driven model, it's actually generating data that otherwise users would not have. These include manually designing and creating 3D elements, such as bridges and new buildings. We have also used satellite data combined with deep learning to identify the location and height of vegetation and key mature trees throughout Hue. An important part of the model is urban master planning. The model allows us to upload regulations around bulk, scale, and location of new buildings to test the rules and to check, eventually, compliance with those rules. One of the use case options for the model is to utilize the 3D model as part of the construction permitting process to enable much easier and quicker response and assessment to permit applications. An application we are currently investigating is the use of the model for height analyses. An important part of Hue future planning is to protect important view corridors to historic sites. So we can upload new buildings and test whether those buildings interrupt important views. New areas can be modeled in real time. This image shows an area of Hue that is currently does not look like that. So this allows us to test quickly new buildings and facades and architectural designs to show them in context to allow planners and government officials to review those proposals. Simple flood analysis can also be done using the 3D data. This area shows the potential flooding using a simple bathtub fill, which is a simple raising of the water level to show how the water interacts with the terrain and also how the floodwaters interact with buildings. So we can see in this image and the next few images how the water looks in 3D. We can visualize how the water flooding affects roads, infrastructure, buildings, and vegetation. And based on this information, we can then make decisions and also bring into the model various solutions. One of the other cities under the Trust Fund that we're working closely with is Makassar in Indonesia. As with other cities around the world, Makassar is facing many challenges to achieve smart and livable future, but it also has significant opportunities for sustainable development. Driven by a forward-thinking and strong vision, Makassar is well positioned, as are many cities within Southeast Asia, to achieve the smart city goal. The Makassar Livable City Plan was developed under the Trust Fund with the support of Makassar City Government and many officials within the university. Makassar Livable City Plan is a suite of digital tools that can be used to integrate Makassar's many existing spatial plans, to enhance future city planning processes, and also to serve as a roadmap for smart and livable investment priorities in Makassar. Data and understanding of that data are key enablers of smart cities. Our work in Makassar started with understanding the local conditions, the local culture, economics, and the environment. We undertook multi-sectoral assessments and carried out citizen engagement to develop bespoke smart city recommendations. We recommended 64 high priority potential interventions to support Makassar smart city vision. The data and analysis and recommendations we made are all collated and communicated through a web-based interactive digital portal. To support Makassar city government decision making, we also developed 4 targeted digital tools, including a unified spatial database, which was a representation of GIS data collated during the project using a simple layered PDF. And that layered PDF can be opened on any device, allowing users to turn on and off layers and interrogate various aspects of the city. We also developed a citizen engagement dashboard using Power BI to enable the interrogation of feedback received regarding government services and the importance and quality of those services from the citizens. This citizen engagement dashboard allowed the city to quickly compare various aspects of city government services. To prioritize those interventions, we developed a prioritization dashboard. And this allows the city to present the expert analysis associated with those smart city interventions and allows city government users to prioritize those interventions. We scored each intervention against a range of criteria and represented that in the dashboard. An important part of the future planning for Makassar is urban resilience. The CSRO in Australia also developed a tool for us under this project called Indra. It's a digital climate resilience platform that allows simple viewing of various climate profiles and various climate impacts. We plotted that spatially over future projections of population and land use to show how climate may affect various groups in the future of Makassar. The next stage for Makassar is to create an integrated digital database, a digital ecosystem, if you like, to make sure we have one source of truth and collect all of the various data that is available within Makassar. And along these lines, the Australian government is starting an open data initiative for federal government data. We're shifting to standardized spatial data formats and data stores nationally. We are using that data via data portals, which are available for all government agencies to use. The federal government's public data policy resources requires all government agencies to make non-sensitive data open. It's an open data portal where all government departments contribute. They provide a catalogue for finding the data, and it also includes a significant amount of spatial data. And using that data is important for all of the states to support ongoing smart city directives. These portals occur in each state through the government agencies, and those portals provide web-based access to that centralized data as a single point of truth. The data catalogs can help people find what they need. These portals are not data stores, but refer to those central data stores nationally. A data portal that has been in operation in New South Wales for many years is the New South Wales Land Use Data Portal, which combines national data with state-produced land use data, which everyone, including citizens, have access to. They have access to planning, zoning, and related information across the state. In the city of Perth, powered by the Internet of Things, Council has open data platform, which is a great example of embedding expertise within government so as to design, develop, test, and maintain low-cost sensors and data integration to deliver outstanding decision-making support for urban planning and government services. We've been lucky enough to work closely with Mr. John Hawke of the City of Perth, who has developed a range of low-cost sensors and integrated databases to monitor key elements of the city. John developed his own open source data management platform and provided access to the public through a range of Power BI dashboards. The journey for Perth City is not stopping. With the embedded localized knowledge and expertise that Perth City has developed, they are now able to innovate and scale up the data to support a wider range of decisions and services. It's through this localized expertise and capacity building we can enable cities to make long-term plans for smart city growth. I thank you very much for your time. Come on, enjoy the rest of your summit. Thank you very much.